Hello and welcome. This is Cambridge O-Levels Physics paper number 1, multiple choice. The subject code is 5054. This is May-June 2020 exam, and this is variant 2 of this exam. Let's start. First question, it says, which one is a vector quantity? Acceleration, yes, acceleration is a vector quantity. Distance, no. Speed, no. Time, no. So yes, the first answer is acceleration, A. Remember, the vector quantity is a quantity which has both magnitude and a direction. Only acceleration among these options have a predefined magnitude and a direction. Next question. Question number 2. The diagram shows the resultant R of a 3 Newton force and a 4 Newton force that is acting on a point P. The angle between 3 Newton force and a 4 Newton force can be of any value from 0 to 90 degrees. Which value of R is not possible? So let's say we have the minimum and maximum conditions. So with these minimum and maximum conditions, we can easily find the minimum and maximum value of this resultant force. So let's see when theta equals to 0. So this is the point P. 4 Newton is acting over here, and similarly 3 Newton is acting. So 4, 3, the overall resultant will be R equals to 7 Newton. Similarly, when theta equals to 90 degrees, 4 Newton is acting in this direction, 3 Newton is acting in this direction. So using the parallelogram law, the resultant R, is equal to 4 square plus 3 square whole under root. This is equal to 5 Newton. So the range of value of R is from 5, that is equal to 7 Newtons. So the resultant vector R will remain between 5 and 7 Newtons for these values of theta. So let's see which values do not correspond to this range. 4 Newton, yes, 4 Newton is not in this range. 5 is there, 6 is there, 7. It's not possible. Answer A is the right choice in this case. Next question. Question number 3, what is measured using a micrometer? So micrometer is used to measure length. So area, no. Current, no. Length, yes. Mass, no. So answer C is the right answer. Question number 4, it says stopwatches are used to time the runners in a race. The stopwatches show the times recorded for the winner and another runner. What is the difference between the winner and the other runner? So one clock watch is showing 57 seconds and 56.76 seconds. The other is showing, so this is 1 minute and 3 seconds. So technically this is 60 plus 3, 63 seconds. So 63 seconds and 84, and that 84 is 1 by 100th of a part. So 76 minus 84, this is 0.8, and 63 minus 6, this is 6.08 is the difference. So what is the difference in time between winner and runner? 6.08. Answer B is the right answer. Next question. Question number 5. Two cameras are at a known distance apart. The exact time that a vehicle passes each of the cameras is recorded. What can be obtained from the information? Average acceleration of the vehicle, average speed of the vehicle, maximum acceleration of the vehicle, maximum speed of the vehicle. Okay, so let's see what is happening. So we have two known cameras, camera 1 over here, camera 1 over here. Okay, so we have the two cameras with us, and so say if a vehicle is passing here, so vehicle passes from here, this camera measures the speed, call it S1. Vehicle passes from here, measures the speed, again S2, and we can also have the time. So we can have easily find out acceleration, that is delta S by T or delta T. So acceleration can be found. So average acceleration of the vehicle can be found out. Yes. Then average speed of the vehicle can be found out. So overall, from this distance to this, we have the distance with us as well, and the time it took from by the vehicle to cover this distance. Yes, we can easily measure the average speed of the vehicle as well. Then maximum acceleration of the vehicle, no, this is not possible. The vehicle may accelerate and then decelerate at this point. The point is only measuring this speed at that instant. The maximum speed of the vehicle, no, again, vehicle may increase the speed in between. And so there is a confusion, or there is uh, a selection which we have to do between the average acceleration of the vehicle and the average speed of the vehicle. Okay, so with the average acceleration, the overall we can say that this we are using speed cameras, and with these speed cameras we can easily measure the speed or the average speed of the vehicle between this distance, and that is having, or this you can say uh, you can say the option will have more precedence over the average acceleration of the vehicle. Okay, so we'll go with answer B in this case. Then question number 6, the weight of the car of weight 11,000 Newton moves at constant velocity along a horizontal road. A driving force of 5,000 Newton acts on the car. What is the opposing motion of the car? So remember, the driving force is the force that is actually driving the car, and that driving force is calculated after all the um, you can say variations that are acting, or sum of all the forward and backward moving forces. So eventually this is the weight. So the opposing force will be the reaction force that is acting on the car, and that reaction force is equal to minus FD, and that minus sign is actually the sign showing that the force is in opposite direction. So that is equal to FD. So answer will A is the right choice. That is 5,000 newtons. Next, question 7. It says a man with an open parachute falls to earth at constant speed. The following forces are acting on the. So let's first of all draw a parachute. Draw a man coming down on a parachute. Number 1, P, upward force of the parachute on the man. So this is force P that is acting. Q, the upward force of man on the earth. Okay. So upward force, say Q, that is of the man on the earth. R is downward force of earth on the parachute. So R is the downward force of earth on the parachute. So this is R. And then the S is the downward force of the man on the parachute. So downward force of the man on the parachute. Okay. So which of the two are Newton's third law pair? So remember, Newton's third law is force, that is action and reaction forces are equal. So in this case, or with these diagram, keeping in mind, we have P is equal to S, or both are action and reaction forces. And so in this case, we have answer number C is the best choice we have in this case. Then question number 8, it says the diagram shows a motorcyclist leaning over in order to turn the corner to the left. Which force causes him to turn? So remember, if a body, if it is turning, or it basically is moving in a circular direction, it means if it's moving in this direction, and if it has to go in a circular direction, then the circular force, or the centripetal force, the force that acts towards the center of the circle, is the one that is responsible for moving the body in a circular path, or allows the body to turn into a, or to take a turn into a circular side. So in this case, we can see that this motorcyclist is leaning towards the left. It means that the centripetal force is towards the left side, or whatever the his turning radius is. The force is towards the center of that radius. So the only direction or only force direction in this direction is A, and so that is that will be the best choice we have for this question. So answer A will be our choice. Next question. It says question number 9. It says an object weighs 40 newtons. On Earth, the gravitational field strength is 10 newtons per kg. The object is taken to another planet where the gravitational field strength is 4 newtons per kg. Which row is correct? Mass of the object and weight of the object on the planet. So first of all, if you have to calculate the mass, so mass of the object is 40 divided by 10 is 4 kilograms. And remember, mass remains the same. So mass remains the same because that's the inherent property of material. Then on weight of the object on the another planet, weight on planet, this is equal to mass multiplied by the gravitational strength of the planet. So mass is 4, gravitational strength is 4 again, so it is 16 newtons per kg. Oh, sorry, 16 newtons. So this will be answer. So answer B will be the best choice we have. Then question number 10. Question number 10 shows the equipment used to determine the density of a liquid. Which equation is used to calculate the density of the liquid? So basically the mass of the liquid plus beaker is given, and we can easily find the volume from here. Okay, so and density, remember, equals to mass per unit volume. Okay, so in this case, what we need to know is first of all mass of so basically what we are given this value, that is mass of water or liquid, not water, liquid plus beaker, and for mass of liquid we have to subtract mass of beaker, and we have to divide it by volume of liquid. Okay, so let's see which is the mass of beaker plus liquid minus mass of beaker divided by volume. So this appears to be correct. Mass of liquid, so no, this will give the not give the density. Again, liquid mass, no. So answer A is the best choice we have. Then question number 11, it says which single item can be used to find the center of mass of a plane lamina of irregular shape. Okay, first, or single item, a balance, no. A measuring tape is not used, a micrometer is not used, a vertical pin, yes. So we suspend the irregular shape lamina from a vertical pin, and with the help of a plumb line we can easily calculate the center of mass of the this irregular shape lamina. So the answer D is the best choice we have. So answer D is the right choice. Next question. Question 12. A student makes a model toy which balances on the end of a metal rod. Why the weights are needed? So why these weights are needed? So these weights are basically counterweights in order to balance this rod, and these weights basically move the center of gravity down towards the metal rod, and lower the center of gravity, or lower the center of mass, basically the more stable or more balanced the rod will be. So first they increase the pressure on the rod, uh, they increase the weight of the model. Yes, both of them are correct, but what exactly they have to do, these both things have to do with balance. It lowers the center of mass from below the top of the rod. Yes, this is right. It raised the, no, it's not right. So answer C is the right choice, because this is the thing that is required to balance the metal and rod. Okay. Next question, question 13. It says an unstretched elastic cord of length 15 centimeters stretches by 4 centimeters when a weight of 6 Newton is suspended from it. The cord extension does not exceed the limit of proportionality. What is the total length of cord when weight of 3 Newton, when the weight is 3 Newton? So remember, extension equals to K times force, directly proportional to force. So, or you can say extension is directly proportional to force and K is the proportionality constant. So our extension is 4 centimeter and K times F is 6 newtons. So our K value is 4 by 6 centimeter per Newton, and this is 2 by 3 centimeter per Newton. So now we have the value of K. Now what will be the value or extension if our weight is 3 newtons? So the extension will be 2 centimeters. So answer A will be the, sorry. So what is the total length of cord? So extension will be 2 centimeter. Total length of cord. So length of cord, actual length L plus extension. So this is 2 centimeter. So total length will be 15 plus 2, 17 centimeters. So do not make this mistake by checking the answer A. Okay. Answer D is the right choice we have. Next question. Question number 40. An object is placed at different depths in liquids of different densities. In which liquid and at what depth is the pressure on the liquid the greatest? Remember, pressure equals to rho gh, density, into gravity multiplied by height. So if gravity is constant, so multiply both of them together. So this is 4,000, this is 10,000, this is 4,800, 4,800, and this is 12,000. Again, so amongst them, this is the most value, or multiplied by G, and G, if it's constant, it means that this value is the best choice we have, and that is the most pressure at that specific depth. Next question. Question number 15. It says a small vessel of volume 3 centimeter cube contains air at pressure of 100 kilopascals. So volume V1 is 3 centimeter cube, pressure P1 is 100 kilopascals. The small vessel is connected to a syringe. The piston is fully inserted into the syringe. So initial volume V2 is 0 centimeter cube, and V2 is again 0, or the piston is moved slowly to the right. So the air in the syringe has a volume of 12 centimeter cube. So air in the syringe now is 12 centimeter cube. The temperature of the air does not change. So temperature is not changing. What is the pressure of air in the syringe? So basically we have to use this law, P1 V1 equals to P2 V2. So my initial pressure is 100 kilopascals multiplied by my volume, that is 3 centimeter cube. My final pressure is something we have to calculate, and my V2 volume is basically when I have pulled the screen 12 centimeter cube, that 12 centimeter cube is here, and this 3 centimeter cube is also added. So it will be 3 plus 12 because both of them are connected to each other. So this will be 15. So this is 3,000 kilopascals, sorry, K multiplied by 15 P2, and P2 is 20 kilopascals. So answer A will be the right answer. Remember, a general mistake that is made by students in this question is that they do not consider this P while using this or while calculating V2. They use 12 and then they divide 300 by 12 and select this answer. So remember, this will give you incorrect answer, and that is not the right way to solve this question. So next question. Question number 16. A rocket of mass m, when empty, carries a mass m of fuel. The rocket and fuel travels at a speed v. The engine of the rocket is fired and all the fuel is expelled. The speed of the rocket increases to 2v. The question is, what happens to the kinetic energy of the rocket? So they are basically asking about a rocket. So say, for example, this is our rocket. So the mass of rocket is m, mass of fuel is m as well. Okay, and it's moving with a velocity v initial. Then after some time, the burners are burned, uh, and the velocity changes to 2v. So the kinetic energy changes. So for the rocket only, so this is the fuel. So kinetic energy of rocket. So remember, only for the rocket, it will be half mass of rocket multiplied by speed square. So half m v square. Then kinetic energy of rocket after burning fuel. This will again be half mr 2v square, and this is 4 times half mv square. So what happens to the kinetic energy of the rocket? It increases by a factor of 4. Answer C is the right answer. Remember, a mistake which in this question, which most of the students have made till now, is that half, they basically add mass of rocket plus mass of fuel. They consider both rocket and fuel as one entity, and they in this case the kinetic energy becomes half mv square, and if they consider the same case, then they have 2 mv square as the kinetic energy after burning the fuels. And in this scenario, they says that the thing doubles 2 times, and they select answer A. So this is not the right choice, at least as per what your marking scheme is saying, because the catch in this question is that you only have to only have to consider the rocket. So if you are only considering the rocket, you do not have to consider the mass that is inside the rocket, although that is or logically that seems to some people it's not the right way of doing it, but that is how this question has been developed. So next question, question number 17, it says the car of mass 1000 kg driven 200 meters up an inclined plane, so that it raises 50 meters vertically. The acceleration of free fall g is 10 meters per second square. What is the gain in gravitational potential energy? So the gain in potential energy, it is potential energy over here is 0. Potential energy over here is mgh. So mass is 1000 multiplied by 10 multiplied by height is 50. So it is 500,000 joules. So answer C is the right choice. Then question number 18, it says in which situation is the energy being released by fusion of hydrogen nuclei from helium? So remember, this is a fusion reaction happening in the center of the sun. So in case of carbon 14 used to date an object, no. In radioactive isotope emitting alpha particles, no. In the center of the earth, no. In the center of the sun, yes. So this is a fusion reaction, and that is happening in the sun. Next question. Question number 19, it says the main stages of operation of a coal power station are listed. They are not in the correct order. So 1, 2, 3, 4, 5, 6 are listed. The flow chart shows the 2 stages. So first stage, number 1, burning of coal produces thermal energy. Number 2 is water in the boiler becomes hot. So this hot water in the boiler then goes to so becomes hot. Then turbine generator, steam turbine, electromagnetic induction steam. So this water becomes hot, and then steam is produced. So this steam is produced. That is your third choice. And after steam is produced, steam is turns the turbine. So this is 4. And the turbine turns the generator. This is 5, and electromagnetic induction produces electrical energy. This is 6. So 4, first of all 4, then 2, then we have 6, then we have 3, then we have 1, and then we have 5. So 6315 is the answer. 6315 A is the right choice in this case. Next question. Question 20. In which situation there is no transfer of energy? The car battery turning the starter motor, the car moving along horizontal road at constant speed, solar panel warming the heater, spacecraft orbiting Earth at constant height. So answer D is the right choice because the spacecraft is traveling in a circular path and there is no transfer of energy because there is no work done while traveling in a circular path. Remember, no work done in traveling in a circular path, okay, at constant speed. Oh, sorry, at constant height. The work done or the energy is zero. There's no transfer of energy. So next question, question 21. It says a 200-volt battery of an electric car is charged with a current of 33 amperes for 4 hours. The efficiency of charging is 90%. How much usable energy is transferred to the battery? Okay, so first of all, we have to energy is kilowatt into hours. So kilowatt, 200 volts multiplied by 33 amperes divided by 1000 and multiply by 4 hours. And energy so this is a unit of energy, yes, but energy is equal to power multiplied by time, and this time is usually in seconds. So if we're talking about not kilowatt hours but joules, so joules, so they are not kilowatt hours, basically we're talking about joules. So 200 multiplied by 33 multiplied by 4 hours into 60 into 60. So this is the total energy that is required and it is 90% efficient. So multiply it by efficiency and efficiency is 90% of 0.9. So if we multiply all these factors together, what comes out to be is 86 megajoules. So answer B is the right choice which we have in this case. Next question, in an experiment to measure the power output of a small steam engine, a known load is lifted by the engine. Which two measuring instruments are required? So load, measuring cylinder and a thermometer. So we are having to measure the power output of a small steam engine. Both are not required. Measuring cylinder and a meter rule. Again, meter rule is needed because we have to measure uh, the height by which the load is lifted. But measuring cylinder, there is no need. I mean, what you have to measuring cylinder is used to measure the liquids, the volume of the liquid. So meter rule, yes. Measuring cylinder, no. Then again, meter rule, we need a meter rule as we have talked earlier. Then stopwatch. So yes, for power output, we need to find out the amount of time till the motor is run. So stopwatch, yes, that will need the time measure it. So yes, this answer C looks good. Stopwatch, yes, we need thermometer. Why? I mean, there is no need to measure to use a thermometer in this case. So answer C is the right choice which we have. Next question. In question 23, it says 4 metal containers with identical dimensions are filled with water at 90 degrees centigrade. All the faces except one of each container are covered with a very good insulator. The one exposed face on each container is painted either black or white. In which container does water cool the fastest? So remember, uh, you know, black and white. So black is a good absorber of you can say heat energy, and it's also a good emitter of the heat energy as well. So white is poor absorber and poor emitter. So if there is if we cover, if we say paint anything or any container with black paint, it will absorb energy it will absorb heat energy quickly, and it will also emit heat energy quickly. And if we coat any material with white, it will take considerable amount of time to emit heat from the water if it is inside. So and the second thing, we have to make sure the water cool fastest. So we have to make sure that we paint the largest area with that specific paint. So for example, in case of in order to cool the water and the water is initially hot, we need to paint the paint, we need to use black paint on the largest face of the container. So first case, yes, it looks a good answer. Large face painted white, no. Small face, so we don't need small faces. So that's, so answer A is the best choice we have. Then question 24, it says thermal energy is used to turn water at 100 degrees centigrade to steam at 100 degrees centigrade. Which of the following occurs? So state change is happening. So the force between the molecules decrease. Uh, so the force between the molecules decrease. Yes, this will happen because the state of the material is changing from water to steam. The speed of the molecule increases. So remember this, if the speed of the molecules increases, it means that the average kinetic energy of the is speed of molecules, say velocity is directly proportional to half mv square of molecules, and the average kinetic energy of molecules is directly proportional to the temperature of the molecule. So it means that the temperature also increases, but temperature is not increasing. So this is not the right answer. Then the separation of molecules increases. Yes, the state is changing. It means that molecules are moved far from each other, or the separation increases. So answer 1 and the C are the best choice, which is 1 and 3 are the best choice. So answer C is the right option we have. Next question. Uh, in this question, it says thermal energy produced, question 25, the thermal energy produced by an electric heater in 3 minutes is used to melt the wax. The solid wax is initially at its melting point of 60 degrees centigrade. The specific latent heat of wax is 220 joules per gram. The heater supplies 7700 joules of thermal energy to the wax. Some of the wax melts. How much wax melts? So remember, this is a question for latent heat, and this latent heat is basically that is uh, 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 can be found out by Q, and Q equals to ml. And and why we are using this, it is because the state of the wax is changing, because its wax is melting. It is not the case where we have the energy is used to raise the temperature of the material. So it is at a constant temperature process. So the energy is given to us, that is 7700 joules. Mass of wax is given to us as oh sorry, the latent mass is we have to calculate, and the latent heat is given to us as 220. So mass comes out to be 7700 divided by 220. This cancels each other. So this is basically m equals to 35 grams. So answer D is the best choice we have. Then next question, question 26. It says what always happens when temperature increases? So when temperature increases, a gas at constant pressure expand. So V1 over T1 equals to constant. Then constant pressure. So V1 by T1 equals to constant. So if temperature increases, uh, uh, we have to make sure that the value of constant this value remains constant. So if T1 is increasing, V1 also increases, so that this constant remains same. So the gas constant pressure expands. So volume increases, the gas expands. Metal rod becomes larger, but its volumes remain same. So no. So if metal large, the volume basically increases. So this is not the right answer. The liquid contracts and then expands. So this only happens for water. That is the enormous expansion of water, but that happens when um, Yes, so it's not all it's not valid for all liquids. It can be only for water as well. Then the hole in the center of a metallic disc becomes smaller. So hole in the metallic disc basically becomes larger. And this is not the case. So this is a metallic disc. So if a temperature increases, this outer disk expands, uh, and this inner disk, the atoms over here are basically stretched in this direction. So the whole, all the radius increases. So the answer A is the best choice we have. Next question, question 27. It says, which row explains why liquid has a fixed volume but does not have fixed shape? So the reason is the force between the liquids is of large nature. The small is for gases. That is not the case. Movement of the liquid. So liquids are the movement of molecules. The molecules are free to move within the liquid, and that is the reason why they take the shape of the container in which they are poured. And for solid, the molecules vibrate at its fixed position. So answer A seems to be the best one. Rest all are not the right choice of answers we have. So answer 27 is the right option. Next question, question 28. It says air in a sealed can is heated. Which statement explains the increase in pressure inside the can? So the molecules collide with the walls of the can more frequently when the air is heated. Yes, pressure is directly proportional to force per unit area. Molecules colliding are actually exerting force on that area, and in a way exerting more pressure. Mass of the molecules is greater, so no, the mass does not change. There are more molecules per unit volume when the air is heated. No, the number of molecules remain same. The separation of molecules becomes greater when the air is heated. So the can is sealed, so air is heated, the separation will become more, but that is not the case over here. So answer A is the best choice we have. Question 29. Next question 29. The distance shown, the diagram shows how height above the ground of rope transmitting a wave varies with distance from the source of vibration at one instant of time. What is the amplitude of the wave shown? So the amplitude of the wave is from the base position to this maximum value. So this is the amplitude of the wave. So this is 40, and this is 1, 2, 4, 6. This is 74. So 74 minus 40, 34 centimeters above the ground. So answer B is the right choice we have in this case. You can, again, the easiest way is to check what is the value below as well. So this value is 2, 4, 6, 8. Sorry, 6, 6. Sorry, 1, 2, 3. So this is 3, 1, 2, 3. So this is 6. So 40 minus 6 is 34. So the amplitude is same above the base position, 34 up and 34 down. So answer B is the right choice. Next question, question 30. It says a vibrator produces 12 wavelengths on the surface of water in 10 seconds. The spacing between first crest and the third crest is 60 centimeter. What is the speed of the wave? Okay, so the first crest wave uh, 3, something like this. So this is the first crest, this is second, and this is third. So technically this is 1 lambda, this is 2 lambda. So this is lambda 1, this is lambda 1. So overall distance is 2 lambda, and 2 lambda is 60 centimeters. So lambda is 60 divided by 2, 30 centimeter. What else? The vibrator produces 12 wavelengths in so time period 12 wavelengths in 10 seconds. Its time period is 1.2 seconds. So frequency is 1 divided by time period. So it is 1 divided by 1.2 seconds. What is the speed of the wave? So v equals to f times lambda. So f is 1 by 1.2 multiplied by 30. So this comes out to be 300 divided by 12. 30 divided by 1.2. No. Wait, 12 wavelengths on the surface of water in 10 seconds. Number of cycles. So this is basically, sorry, this is frequency. Number of cycles per unit time. So this is frequency. My bad. So this is frequency. So frequency is 1.2. And 1.2 multiplied by 30 is 36 centimeters per second. So this is so answer C is the right choice in this case. So remember, number of wavelengths per unit second is the frequency. Next question, question 31. It says the diagram shows a ray of light incident on boundary between two mediums W and X. The mediums have different refractive indices. Some light is reflected and some passes along the surface between two mediums. The angle Y is larger than angle Z. So angle Y is larger than angle Z. Okay. Which statement is correct? W has greater index. W has greater index than X, and angle Y is equal to the critical angle. So remember, critical angle is the angle so for example, the best way to remember this, consider the use of critical angle. So the critical angle is used in optical fibers mostly for communication purposes. So the light ray is entering from the air into the fiber, and at the fiber it goes, strikes the boundary, and is totally internally reflected. Okay, then strikes the angle. So basically, there is the light is actually moving from two different mediums. So this is glass and this is air. So the angle of incidence such that it is greater than angle of the total critical the angle of incidence is such that the angle is greater than the total angle is greater than the critical angle, then the light is critically reflected. So it means the light should be entering from a denser medium to a rarer medium, and theta I, angle of incidence, should be greater than theta C. Okay, so this is you can say glass and this is air. So Nx is greater than Nw, and theta I, angle of incidence, is this Y, and critical angle, this is the critical angle theta C. So theta C is equal to Z. So the angle of incidence theta I should be greater than theta C. So it means that Y should be greater than Z, or greater than equal to angle of incidence to be greater than equal to critical angle. That is the case, or yes. So that is the case when we have total internal reflection. So let's see what's the option is correct. So W has greater refractive index than X. So W no. W no. W has greater refractive index than X. No. First, X has greater refractive index than W. Yes. And angle Y is equal to the critical angle. So in theta of incidence should be greater than equal to theta C. Yes, this looks good. And greater than X has greater refractive index than W. Yes. Angle Z is equal to the critical angle. No. So angle Z is nothing. It is not the angle of incidence. And why angle of incidence? Because of law of reflections, theta incidence equals to the angle of reflection. So answer C is the best choice we have in this case. Okay. Next question. Question 32. It says light enters a glass block at an angle of incidence theta I. It produces an angle of reflection, refraction in the glass. Okay. So several different values of I and R are measured, and graph is shown of sine I against sine R. Which graph is correct? So remember N air, so and this is N glass. The refractive index of air is 1 and N glass is approximately 1.5. So according to Snell's law, Na sine of theta I is equal to Ng sine of theta R. So sine of theta I over sine of theta R is equal to Ng over Na. This is approximately equals to 1.5. And the graphs, on the graph we have this theta I on the y-axis, on theta R on the x-axis. So this is if we are going to measure the slope delta y by delta x. So it means that the slope of the graph must be equal to 1.5. So let's see which graph has slope of 1.5. So first graph on x-axis sine r, sine r, sine. So that is fine. Sine I, sine I, sine. So all the graphs will be are same. This is 0.5 and the corresponding value over here is say 0.75. So if I'm going to find out the slope 0.75 divided by 0.5, this comes out to be 1.5. Okay, so this is something which I'm looking for. This is a good one. In this case, so at 0.5, my slope is minus say 0.25 divided by 0.5. So this is not something I'm looking for. Again, this is a negative slope graph. I'm not looking for a negative slope. Then at 0.5, this value is something around 0.3. And again, this slope is say 0.25, you can call it, or divide by 0.5, so it is 1 by 2. So this is again not the one I'm looking for. The answer A is the best choice we have, and that slope matches what the value we are looking for our graph. Okay, so the next question 33, it says the converging lens is used to produce a virtual magnified image. Which ray diagram shows the rays passing through the converging lens? So remember, this is a diverging lens, this is a converging lens, this is a diverging lens, this is a converging lens. So the ray, so we are basically virtual and magnified image. So for a converging lens, a virtual and magnified image is formed on the same side of the object. So this image will be also basically this image will be virtual and magnified. So this is how this image will look like, and virtual and magnified on the same side of the object, and this is magnified as well, we can see that, and it is uh, not inverted. So real images are inverted images, virtual images are not inverted images. So answer D is, or D is the best case we have. So in case of B, remember the image will be, although it will be enlarged, magnified, but it will be an inverted image and it's on the other side of the lens, and that makes it a real image. So next question, question number 34. It says a metal lightning conductor is placed on top of a building. The conductor is connected to earth. When a charge cloud passes over the building, the metal lightning conductor becomes positively charged. Okay. What happens to the lightning conductor to produce positive charge at its top? So positive charges, uh, electrons move downwards and proton moves upward in the conductor. So protons do not move. I mean, so only electrons move in the conductor. Yes, only protons do not move. Protons in the air, so there's no protons in the air. So answer B is the right choice we have in this case. Next question, question 35. It says two insulated and uncharged metal spheres X and Y are touching. The positively charged rod is held near X, and when the spheres are moved apart, now X has negative charge. So when these two spheres are touching, so negative charge is here, positive charges are here, negative charges are here, and positive charges are moved here. These negative and positive cancels out each other, and when these two spheres are turned apart, X will have 1, 2, 3 negative charges, and Y will have 1, 2, 3 positive charges. And this is how these two spheres will behave. So what is the charge on Y? Charge on Y would be positives, negative, no, positive, yes. Smaller than X, no, it will be equal, equal in size or equal in quantity. So positive and same in size as of X. So answer D is the best case we have. Then question number 36, it says a stationary negative charge. So stationary negative charge in an electric field experience an electric force in the direction shown. So the charge is not moving, it is stationary. Okay, so remember, if we have an electric field, so electric field will always be from positive to the negative end. So the field lines would be something like this. And if a stationary negative charge or a stationary electron, you can say, is here, these electrons will be pulled towards the negative side or will experience a force here. So this will not like this, it will experience a force in this direction. So it means that the positive end is here and the negative end is here, and the electric field direction is in this direction. So what is the direction of the electric field? The electric field direction is from right to left. To the left, yes. To the right, no. Down the page, no. Up the page, no. So answer A is the right choice we have. Next question, question 37. It says a metal length of wire L and a cross-sectional area A has a resistance R. Okay, so resistance equals to rho L by A. A second wire is made up of same metal and it has a length uh, 2L, cross-sectional area of 4A. What is the resistance of the second wire? So the resistance is rho L divided by 2A. And this is 1 by 2 times R, that is calculated over here. So it is R by 2. Answer C is the right choice we have. Next question, question 38. It says it says the diagram shows a circuit. So we are shown a circuit diagram. What is the effect on closing the switch on the readings of ammeters X and Y? So initially this circuit is going is like this. So current I is flowing, current I is flowing. This is a resistance R, this is a resistance R. So overall you can say I equals to V by R. Ohm's law, total resistance voltage is this, so total resistance is 2R. So the current I, so reading X is equal to Y, and the value of current that is showing is V by 2R. Okay, value of I in this. Now if switch is closed, my equivalent circuit would look something like this. Now this is R, this is V, this is actually short circuited, so no current will flow in this direction. Okay, no current will flow in the direction below. So just this value, so I will be equal to V by R. So ammeter reading is will be reading at X. So reading on X basically does what? So it increases. So increases or it doubles. So reading on X increases. Reading on ammeter Y, it decreases or it goes to 0. So reading on ammeter X increases, ammeter Y decreases. So answer C is the right choice we have. Next question, question 39. It says a rectangular current carrying coil is pivoted between poles of an electromagnet. Which action does not on its own increase the size of turning effect exerted on the coil? Increasing the current in the in the coils of the electromagnet, yes, the coil will start to turn, or the increase in speed of turning, increase the current in the rectangular coil, it will again change, reverse the current in the electromagnet. So if the current is reversed, the direction of rotation will be reversed, but there is no effect on on the turning effect or the rotation of the coil. So this is something, increasing the number of turns will increase the speed or increase the turning effect of the motion. So answer C is the best choice we have in this case. Next question, or the last question for this exam, question number 40. It says the diagram shows a coil connected to a very sensitive ammeter. The magnet is next to a coil. Which action results in zero reading on the ammeter? So remember, if the coil is moved towards so if the magnet is moved towards the coil or magnet is moved away from the coil, keeping the coil stationary, it will change the reading on the ammeter. Or if the magnet is stationary and the coil is moved either right or left, it will change the readings on the. So moving the coil and magnet at same speed in opposite directions. So this is moved in this direction, this is moved in this direction, it will change the reading on ammeter. So this is not the answer. Moving coil and magnet at same speed in the same direction, so both are moving in the same direction, so technically there is no flux or the rate of change of magnetic flux across these coils. So there is no reading on the ammeter. Yes, moving coil away from the stationary magnets, there will be rate of change of flux across these coils. So no, this will change the reading or this will give ammeter some rate. Moving the magnet towards the coil will change or will cause rate of change of flux, and that will cause some reading on the ammeter. So answer B is the best choice we have in this case. Okay, so this is how basically we solve these questions, and uh, this is all from this exam. And I hope you have learned a lot, and I hope I was able to, you know, uh, address your questions and queries. And if you have any other questions, please do not forget to comment in the comment section. uh, so if you like the video, do like it and recommend it to your friends. And in the end, I wish you best of luck for your exams and future endeavors. Thank you for listening. Take care. Bye bye.